Hi guys, this is Mr. Gagnon again, best of played at 1.25 speed from YouTube. So we've been looking at frictional forces. Now we're going to take a look at, we looked at kinetic friction. Now we're going to take a look at static friction. Okay. Now, I'm going to give you one more formula to look at for static friction. Now, we said the frictional force, static, is equivalent to this mu value, but we're going to call it static mu, times the normal force. So, rather than complicating things like I did in the last video, let's clear it up a little bit, and let's just concentrate on getting what the frictional force is. Now, on page, I want to say page 120 of the notes, okay, you're going to find a, a value that has both static and kinetic coefficients of friction. Okay, just a little recap. Static friction is always greater than kinetic friction. Okay? Now, let's simplify this a bit. Okay, I'm going to give you the normal force, okay, and I'm going to give you the mu, and all I want you to do is look for the static frictional force. Okay, let's say I have an object. It's got a weight of 10 newtons. Okay. Okay, this is the applied, this is the normal, and this is the static frictional force, FFS. Okay, in this problem, I'm not going to get into what this is, but I will say that you'll have to understand that the normal force is the same as the weight in the opposite direction. So the normal force is 10 newtons. Okay? So if the normal force is 10 newtons, I've got it. If I tell you what surfaces we're looking at, you've got it as well. So let's just say, if you're looking at page 120 of the notes, okay, I'm going to say that we're looking at rubber. Okay, we're going to say that this surface is rubber, and this surface is concrete. Okay, so we've got a rubber block on concrete. So a rubber block on concrete, the mu value, and that's always going to be the same, of static mu sub s, is 1.0. Okay, so the mu value is 1, and then we don't get the static confused with the kinetic. We're looking for static friction. This block is not moving. Okay, we're pulling on it, but it's not moving. So the static friction is going to be easily found as the force of friction static is equal to mu s times the normal force. Or, said that this was 1. The normal force was 10 newtons. So we ended up finding the static friction as 10 newtons. Okay? Because our mu value was so high. And by the way, we don't go much higher than 1 for the mu value between two surfaces. So rubber on concrete provides a pretty solid sticky surface. Now, let's just say that this thing starts moving. Once this thing starts moving, we're not looking for the static friction anymore, but we're looking for the kinetic friction. So, in our values, the mu sub s was 1. Now, on this page 120, it also goes to say that the kinetic friction is 0.8. Okay, so does that make sense? Static is greater than kinetic. Now, this is all found in that table on page 120. So, let's find out the static friction between rubber and concrete. Okay, I'm going to reverse that. We've already found the static friction, but let's find the kinetic friction of rubber on concrete. Okay, it was 0.8. The mu was 0.8. Normal force is 10. Okay, so the force of friction kinetic while it's moving is going to be 0.8 times 10, or 8 newtons. Okay, so notice that the friction now this is still, this is moving. So once it breaks free, it's now got moving friction of 8. It's harder to break it free, so it's got a friction of 10 to start. Okay, so this just describes a little bit on how to get friction. Now, I'm going to tie it together in the next video, because eventually we are going to have to get that acceleration of the block given some static and kinetic friction values.